Our next guest speaker is Dr. Sebastian Stern from AWS Professional Services. In his role, he builds solutions leveraging emerging cloud technology for AWS customers and accelerates their platform adoption. He's also a member of AWS Quantum team and onboards customers on Amazon Braket. In this role, we'll hear from him today on quantum computing in the cloud with Amazon Braket. Welcome to you, and the floor is yours.
Thank you very much for the kind introduction, and good morning and welcome to my presentation about quantum computing in the cloud with Amazon Braket. In the next 18 minutes or so, I would like to inform you about quantum computing initiatives at AWS. I introduce our quantum computing service, Amazon Braket, and highlights its core features and capabilities. Before that, I want to thank the organizers of this event for the opportunity to speak today. I think the potential of quantum computing in providing massive speed up in computation for a specific class of problems is well known, and also the current state of the technology is also covered in some sessions during the summit. So I will not review or summarize, I will just refer to it. And I want to start with that we at AWS, we are humble about the technological and scientific challenges ahead of the quantum computing community. And we acknowledge that the technology is still in its infancy pretty much. But at the same time, we are excited about its potential, and we see that many of our customers or that for many of our customers, now is the right time to start with quantum computing and start to research their applications, build expertise, and innovate in that field. So we position ourselves to help our customers to start this experimentation. And also, we want to allow them to sort of cut through the current hype and want to enable them to compare different technologies and explore if and when quantum computing will matter for their business. So to do so, the quantum computing program of AWS is built on 4 pillars. First, we have the AWS Center for Quantum Computing, and its focus is R&D. CQC is a research center close to Caltech, where we brought together some of the world's leading quantum computing researchers and engineers with the mission to accelerate development of quantum computing hardware and software. Second, we have the Quantum Solutions Lab. And this is a collaborative research program that allows customers to work with the leading experts in state-of-the-art quantum computing, but also machine learning and HPC. And the program is meant to identify the most promising applications for quantum computing for the specific customer businesses, and then to accelerate that they can build on up internal expertise. Third, there is a growing global community of technology and consulting partners with specialized skills in quantum computing. We collaborate with partners either specialized on key use cases like optimization, for example, or QML or others, or with key industry verticals, for example, financial services or automotive. And we help our customers also to identify the right partners for their business. So that is pretty close to the second pillar, the Quantum Solutions Lab, because it's about knowledge sharing and knowledge building. Then finally, now there is Amazon Braket. And this is our fully managed service, generally available and designed for developing quantum computing algorithms and for experimenting with quantum computers from multiple hardware providers. So let's double click into Amazon Braket. Because it is a fully managed service, users do not have to bother spinning up infrastructure and operating it. And this is an advantage for scientists and also developers, because it makes it easy for them to start, and it frees their mind to focus on the work they actually want to do about quantum computing. Amazon Braket provides a technology agnostic programming environment So it is possible to run algorithms on actual quantum computers from different hardware providers or on managed simulators, so classical compute, in order to test and debug your algorithms before start running on a real quantum hardware. And being able to run these algorithms on different devices means that you can directly compare technologies and assess which quantum hardware will best fit to the different use cases. So let's have a closer look at how Braket actually works. This is a pretty full slide, and it should give an overview how Braket is built and how users can interact with it. Also here on the very right, you see full integrations with other AWS services, for example, for monitoring or data storage. I will not cover that in great detail. Let's more focus on the service itself. And let's start with the interaction part. So like many other AWS services, everything in Braket is behind an API. And to make everyone's life easier, there are multiple ways to interact with that API. Starting from the bottom, there is a dedicated web console, the Amazon Braket console, that offers a convenient way to monitor the state and the availability of quantum devices, of the simulators, and also allows you to track the status of your jobs and tasks. And then there is a dedicated open sourced Python SDK. It can be pip installed on basically every local or remote environment. And it conveniently simplifies the tasks of designing your circuits and submitting it to Braket. Amazon Braket then also provides managed Jupyter notebooks that come pre-installed with the Braket SDK again, and you can start using with these managed notebooks the service without having to set up or manage any kind of infrastructure or local environment. So this is how you interact with the service. And now let's have a look at the devices behind the scenes. I started with the local simulators, and Amazon Braket comes with different flavors of classical compute quantum simulators. And as I said before, they are best to really start building and testing and debugging your circuits, and they behave as a noise-free environment, most of them at least. And we have 3 different managed simulators, but the SDK itself already comes with built-in local simulator. And this is really best suited for rapid prototyping. It does not require any connectivity to an AWS environment at all. The results are computed in the session. So you could actually download the SDK and start without having even an AWS account, leveraging Braket and designing circuits on a local simulator. Then, clearly, as the local simulator is running in your session, the performance depends a bit on the hardware specifications. But as a good rule of thumb, that simulator is suitable for circuits with up to 20, maybe 25 qubits. So then let's move to the managed simulators. And since they are managed, that means you're not managing the hardware yourself, but you're submitting your tasks to a job queue, basically. And we have first the state vector simulator that takes into account the full state vector, sequentially applies the gate operations. And as this is a bit computational or actually memory intense, obviously there is a practical constraint due to hardware limitations also here. And with SV1, you can simulate circuits with up to 34 qubits. Then we have the Tensor network simulator. This is a specialized simulator, I would say, not a multi-purpose simulator like SV1. It does not encode the full wave function. It does encode the circuit in a structured graph. And then the graph is analyzed and only efficient graph traversals are retained. So therefore you can simulate circuits with more qubits. But on the other hand, the structure of the circuit really determines the runtime also in that simulator. And normally sparse circuits or, for example, quantum Fourier transform algorithms are quite suitable for TN1. But before starting a large simulation, you should obviously qualify that this is the right choice for the problem. Finally, our latest addition to our simulator family, and that's density matrix simulator. And that is intended to really simulate circuits with noise. It comes with pre-built different noise channels like bit flip or phase flip and so on, and also allows you to create your own noise channels. And that allows you to study error mitigation strategy or build, robust algorithms suitable for the current state of today's QPUs. It lets you simulate circuits up to 17 qubits. Now, the core of the service obviously is giving access to real quantum hardware. And a core design feature is giving that access in a unified way to multiple QPUs from different hardware providers built with different technologies. And this is really reflecting how we see quantum computing at AWS, because as the technology is still in its infancy and there isn't any fault-tolerant universal QPU available today, there are different technologies on the market which are interesting and which have different, for example, scaling capabilities, or the device configurations are more or less suitable for certain circuit structures. So we really believe that for our customers, for the users we have on the platform, it's beneficial that they can experiment with various different technologies. And this is how we call it democratizing access to quantum computing. And that's at the core of the service. So our portfolio of QPUs has evolved over time and will continue to evolve. Currently, in this screenshot, this is taken from the Braket device page, so from the web console. You can see that we have 2 quantum annealers from D-Wave available. So those devices typically have a large number of qubits, right? And they are suitable for specific type of problems, for example, in optimization. So we have devices with 500, 7,000 and 2,000 qubits. They are available 24/7, by the way. And then we have currently 3 gate model QPUs. And there is IonQ, an IonQ device with 11 qubits, having all-to-all qubit connectivity. We have a Rigetti Aspen M1 with 80 qubits that comes with octagonal topology where the octagons are interconnected. So that gives you 2-fold and 3-fold qubit connectivity. And our recent addition is Lucy from Oxford Quantum Circuits with their interpretation of an 8-qubit superconducting device. Oxford Quantum Circuits is a UK-based startup, and we are very excited about having our first device located in Europe on the platform, and we're also supporting the community there. And I can also already share that pretty soon we will add another device, one from QEra in Boston. That is based then on Rydberg atom technology. And it's interesting as it will complement the set of device technologies we can offer. And there is also exciting research going on that shows that devices could be well suited for such devices could be well suited for simulating variety of natural systems. So we're excited to see what our customers build with those devices. And in the fullness of time, we are committed that we will continue to add more hardware designs as they become promising and available. Now, so far we talked about how Braket works, or how Braket is built up and what devices are available. But now I want to highlight one of the latest features to the service, and that is called Amazon Braket Hybrid Jobs. And with that, I will also want to start moving towards how to build on Amazon Braket. Hybrid classical algorithms are very interesting, especially nowadays as they optimize the performance of today's devices. And such algorithms follow the concept to offload only parts of the computation to the quantum device. So basically this QPU acts as a co-processor. And well-known use cases for these patterns are, for example, variational quantum eigensolver or QAOA or QML type of workloads. Amazon Braket Hybrid Jobs is built to enable to run those kind of workloads easily. So it manages the classical EC2 job instance. So it makes it much more convenient to create and run those type of algorithms. And it gives you customizable insights also in the job execution. The tasks get priority on the job queues. And also you can either use a pre-built container for the job instance, coming with commonly used Python libraries, or you can even bring your own container, meaning you define an image and push it to Amazon Elastic Container Registry to bootstrap your job container from that. And so you have full control over your job environment. Now, I want to come slightly so closely to an end, and I would like to spend the remaining time giving you an idea how we support our customers building on the platform. And above everything, our customers build on AWS. What they build on AWS is their IP, and so they decide whether they publish or not. And we support them either in their problem definitions directly and solving the problems directly, or we deliver also thought leadership in general solutions we publish ourselves, or we support public customer or community events, I would say. And I want to give you two examples to that. So the first is how you build on AWS. And this is often underestimated, that Braket is just one of the more than 175 services in the cloud. And it makes it perfect to build end-to-end solutions. So for example, you could create a solution in which quantum computing is just a part of an integrated event-driven solution, how it is displayed on the right-hand side. Or on the other hand, you could build solutions for certain business use cases. For example, on the left, where you see a design for a public API behind an authentication layer that giving access to quantum and high-performance computing resources. So it's really something, especially our commercial and commercial customers and partners are asking us a lot for. So building those end-to-end solutions. And then finally, just another highlight. So we collaborated last year with BMW on their quantum computing challenge. And this is a nice example for the interplay of a customer use case and community activities. This is I'm running a bit out of time, so this is also published on blog posts. I would encourage you to check out our blog posts page for more use cases we publish or for more solutions we publish. And I would like to now thank you for having me. It was a great pleasure to speak to you today. And also my email is listed there. So please reach out if you want to learn more about Braket or quantum in general, and I'd be happy to understand if Amazon Braket could be also useful for you.